Hello guys, welcome back to Edexcel Science channel. And now we are at question 15 from 2026 June IAL Physics Unit 2 paper from Edexcel. So question number 15 is saying a car battery has an electromotive force EMF of 12 volts and an internal resistance of 0.05 ohms. State what is meant by EMF. So the way I always remember it is through the basic formula of voltage, which is energy per unit charge. And that is EMF basically. Okay. So you can say that it is the energy supplied per unit charge. Okay. All right. Question number B. The circuit diagram shows the car battery connected to the starter motor of a car. The starter motor has a very small resistance as it needs a large current to work. The starter motor has a resistance of 93 milliohms. So the resistance of this part is 93 milliohms. Okay. Determine the terminal potential difference across the battery when the switch is closed. So guys, what is the terminal potential difference? The voltage that is written on the battery is 12 volts. But if you use a voltmeter, if you use an ampere meter over here, you not ampere meter, sorry. If you use a voltmeter around this component, okay, if you use a voltmeter around this component, you will never get 12 volts. The reason being is that the battery itself has some amount of resistance which will take some share of this electromotive force or the EMF. So the potential difference that is available in the circuit after the internal resistance has taken some of the volt, that is called the terminal potential difference. So in this explanation, we can actually develop a formula which is that the EMF is going to be distributed among the terminal potential difference, which is, let's call it Vt, and the lost volts. The lost volts are the voltage that is being lost due to the internal resistance. Now, I can find out the terminal potential difference by subtracting the lost volts from the EMF. Okay. But how do I find out my lost volts? Now, I know that the entire circuit has a resistance of 0.05 and this resistance added together. They also have a voltage of 12. So now I can find out the current. So current is V over R. Total voltage is 12 and the resistance is 0.05 plus 93 times 10 to the power minus 3 to convert it to ohms. So the current that we have is 84 amperes, which is very, 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 very high. Okay. Now I can find out my terminal potential difference. That is this formula, this equation. EMF is 12 and the lost volts is I times small r. Small r is the internal resistance. So 12 minus 84 times 0.05, and that is going to give you 7.8 volts. And this is the terminal potential difference. But I believe you can do it in another way. Okay, let's call it way number one. If you think, if you find this process difficult, then you can actually do another way. Let's call it way number two. Way number two is using potential divider circuit. imagine that this circuit is a potential divider circuit. Why? Because this battery has a EMF of 12, which is going to be distributed among the internal resistance and this component. So in a way, we can say that the potential is being divided, right? So I can use the ratio of resistances to find out the potential difference. So in this case, I have to find out the voltage around the motor. So I can say that across voltage across motor or voltage of motor is equals to the ratio of its resistance. So the resistance of the motor is 93 times 10 to the power minus 3, and the total resistance is 0.05 added with 93 times 10 to the power minus 3, and the total voltage input in this circuit is 12 volts. And in that way, you can also find 7.8 volts. Okay. As you can see, this process is much more easier, but whichever way you go for it, you will get full marks. No problem. Question number 2. After a few years, the battery will have a greater internal resistance. Explain why this could prevent the starter motor from working. So guys, in the question, they tell us that the starter motor has a very small resistance. Why? Because it needs a large current to work. So if the resistance increases, right, then the terminal potential difference will decrease even more. So the current will decrease. Okay, let me draw a flow chart. If the internal resistance increases, then the total resistance will also increase. Wait, if small r increases, then capital R will increase. So my terminal potential difference will also decrease. So the current will decrease, right? So the starter motor will not work anymore. So I can say that terminal potential difference will decrease. Therefore, current will decrease. Current will decrease, and the current will. It says in the question that it needs a large current. So therefore, the current will not be high enough for the motor to work. Okay, the current will no longer be high enough to for the motor to work. Okay, so that is it for question number 15, guys. I hope that this is much more clear to you guys. Please don't forget to like and subscribe to the channel. It really motivates me to make more videos for you guys. And I'll see you in the next video.